Mechanical energy can be divided into two, in which you have kinetic energy and you have potential energy. Potential energy can then further be divided into gravitational potential and elastic potential. That means potential energy can express itself in two forms. Now, these three energy stores, in real life situations, they don't exist alone. You usually have a combination of kinetic and gravitational potential, as the case may be, in different quantities, and even in some cases you have elastic potential coming into the party. So we have a question here that gives us a picture of what we're talking about. Now the question says the mass of the student. Now the diagram for the question is on the worksheet here. So the question says the mass of the student is 60.0 kilograms. The gravitational field strength is 9.8 Newton per kilograms. Then the bungee cord has an unstretched length of 30 meters. So those are just things given to us from the question, and we're left to work the other things out ourselves. All right. So, what are we asked to do? We're asked to calculate the change in GPE. GPE is the gravitational potential energy. Now, the student right here, the bungee cord attached to the student, once he jumps to this point, the student will not put too much stress. We're just assuming here. So without putting too much stress on the bungee cord, we're going to have 30 meters. That's why you have on the question, it says the unstretched length. Okay, so invariably the cord can actually move more than that, can extend beyond 30 meters. Okay, so calculate the change in GPE. GPE is the gravitational potential energy. And what's the formula for GPE? The formula for GPE, that's gravitational potential energy, is mass times acceleration due to gravity times height. And then let's see what we got from the question. We've got the mass of the student as 60 kilograms. We've got the gravitational potential as 9.8 newtons per kilograms. What else? We've got the height as 30 meters. Simple, right? Then you just slot all this into this guy right here, and that will be GPE equals the mass of 60 kilograms. The acceleration, the gravitational field strength rather, is 9.8 newtons per kilograms, and then the height is 30 meters. Easy peasy. You would have 17,640 joules. Okay, right there, the question now says we should also calculate the maximum change in GPE, So here we're assuming that the student, after jumping, has the highest length that the cord can achieve, and that you have right here, which is 75 meters. So when the cord is stretched to its limit, you'll have 75 meters. That's the highest here. So what we're expected to do here is the change in height, which is 75. So the student jumping from 0 height to 75. Now, do not make the mistake of assuming that here what we're going to do here is just to assume it's from 30 to 75. No, the maximum GPE, and that will only occur when the student jumps from height 0 to height 75. So here, all we're going to change is the H. Will change our H to 75. So doing that, we would have GPE equals mass, still the same, 60, and we have the gravitational field strength 9.8, and we have the height now, which is 75 meters. and this should give you 44,100 joules. Okay, and let's see what else we have here. The speed of a student after falling 30 meters, if 90% of the GPE is transferred to the student's KE store. Now, the KE you have there, that is talking about kinetic energy. That's kinetic energy and play there. So here, what this is saying is after the student has jumped to a height 30 meters, the total energy, which is 100%, let's just assume the total energy in this case is 100% in GPE. It's only 90% that was transferred to the kinetic energy store. So all we have to do here, is just to say that from GPE to KE, only 90% was transferred. Okay, so we'll have 90%, and the GPE will have at 30 meters. Note, at 30 meters. So you won't go about imputing the GPE at 75. Okay, it was stated specifically in the question that GPE at 30 meters. That's what we're working with. All right, so we just do 90% of GPE at 30 meters. That's all we need. That's all we need. So what's the GPE at 30 meters? Well, let's check. We've got 17,640 joules. So that would be 90% of 17,640 joules. That would be 90 over 100 times 17,640 joules. This will definitely give you the KE at 30 meters will be 15,876 joules. Okay, that's the kinetic energy at 30 meters. So now on the flip side, this is just the first part of question C. The second part of question C is now saying that we should calculate the speed at this point. We should calculate the speed. You've got the speed as the velocity. So what's the equation for kinetic energy in this case? That's kinetic energy equals half mv squared. Half mv squared. And the next thing you have to do is, since v is the speed, you have to make v the subject. The m here stands for mass, the v stands for speed, velocity, the KE you have here stands for kinetic energy. So we've got the kinetic energy here as 15,876. We've got the mass as 60 kg, the mass of the student. So the only thing we need to get is the speed. In fact, that's what we want to get from the question. So that will be, so then we'll make V the subject. So if you want to make V the subject here, let's just flip this. mv squared equals KE. Then you have 2KE. You do that by cross multiplying. Then you divide by m. You've got 2KE over m. What else do we need to do? Then you take the square root of both sides. Then you have 2 times kinetic energy over m. And this will be square root of 2 times, what's the kinetic energy of 30 meters? 15,876. 15,876 joules. Definitely this will give you 3 meters per second. And the last part of the question says the spring constant of the bungee cord, if all the GPE is transferred to the bungee cord's elastic store. The elastic store can only be maximum. We're answering question D now. The elastic store can only be maximum at the highest stretch, okay, at the maximum stretch of the cord. So if this cord has not been stretched to its maximum point, then the elastic store it will not be maximum. So the only point here where the elastic store is maximum is at 75 meters, extension of 75 meters. Okay, now the only thing we need to take care of is that the extension is, okay, let me just write this down. For question D, the extension equals the final length minus the original length. So in this case, if we are to make, if we are to tweak this to answer this question, we'll say extension is the stretched chord minus unstretched chord length. So here you have stretched chord length. So the stretched chord length is at 75 meters. The unstretched chord length is at 30 meters. And here we have an extension of 45 meters. And right after that, we'll have elastic potential equals have times spring constant times extension squared. That's the equation for the elastic potential. Now the question is saying at that point, 100% of the GPE is transferred to the elastic potential. GPE at that point is, that's the GPE at 75, that's the maximum GPE. We've got that as 44,100. 44,100. So here, all we have to do here is to make the spring constant the subject. So let's just flip this. KE squared equals elastic potential. Same thing. KE squared equals 2 times elastic potential. K equals 2 times elastic potential divided by E squared. And when you substitute the values, you have 2 times 44,100 joules. Since all the GPE at 75 is transferred into the elastic potential, and down here you've got the extension at as 45 squared. This would give you 43.6. Now spring constant is measured in Newton per meters, or you can have it as 43.6 Nm raised to the power of -1, still correct, or you can round this guys up to 44 newtons per meter. So that's it guys for this video. Please do well to like, subscribe, and share this video if you learned something. Thank you very much, and I'll see you in the next video.